natural log. So see, this is the natural log. What do you know about the natural log? What is the meaning of actually the natural log? Yes, anyone? If I will ask you what is the natural log, meaning what? The natural log is nothing but this natural response. The natural response, that means what? This circuit does not including the initial condition, but input supplied are present. Okay? And the forced response means what? The forced response is the circuit does when the external source, that means initial condition set 0. What you said here, the initial condition 0. That means what? The total response is the sum of the forced response plus the natural response. So this process, it is called the natural and forced response. Okay? Now you can see here. So this is the natural force. So this RC circuit, this one has the RC circuit, again they have the T equal to 0. So we have calculate here RC. The RC means they have the series combinations, resistor and capacitor. So we have written, first we can see here that across this capacitor, the voltage is VC equal to input supply. So input supply, what do you have? The Vs. So this VC, when the T equal to 0, so VC became VC0 equal to, that means input sources, the input voltage source. So if the T equal to 0, that means what? The this 0 became managed. Managed indication is initial condition. The switch is turned off. Okay? The when this turn off equal to input source equal to supply voltage. The supply voltage, that means the switch is on. The VC of 0 plus this became. Okay? Now you can see by this natural response, they have said the RC circuit they need. The RC circuit, that means the combination of resistor and capacitor on the series combination. So they will be replaced here because we want to calculate when the switch is on. So when the switch is on, so this switch off condition is replaced here and they will become like this diagram. So resistor and this capacitor, and this totally they will be replaced. So again I have draw here circuit diagram with capacitor and resistor. So across capacitor current will flow IC and across resistor the current will flow IC. So this is the closed loop. Again we can prepare the equation here. The IC plus IR equal to 0. Now differentiate this capacitor I, so it became the C dV divided by dt and plus I equal to what according to Ohm's law? V divided by R. So we have written the V divided by R equal to 0. So here voltage is across the capacitor V of T equal to output voltage of capacitor, and this part because this have the constant here, so this became here exponential. So this is the RC circuit, so we have written here the tau because here it became the tau equal to RC. The tau equal to RC, that means here this V divided by R also it is there. So this exponential minus T divided by tau directly we have written. So this IR, now calculate the IR. So IR equal to what? V divided by R. So we have written the V divided by R. When is the T equal to 0? So when the T equal to 0, across this V they became 0. initial condition. So V of 0 divided by R and exponential. This is the RC circuit. So E exponential t divided by 2. Okay. So now these I are equal to V divided by R and V naught R E exponential t divided by 2. Now again calculate the power. So when the power will calculate this I into V. So what you have the I value? The I value you have V0 divided by R E exponential t divided by tau. Now V value, what do you have? The V value becomes V0 E exponential t divided by tau. So you can put here this value and multiply these both. Then become this power V0 squared divided by R E exponential. This E exponential, see here they have the double times. So we have written here E exponential minus 2 t divided by tau. Now get the energy. So integrate 0 t PD t. So they will be have the half and this CV is squared and this 1 minus E exponential 2t divided by this tau. So this is the our energy. Now see this problem how to solve for the natural response. So this is the diagrams here and you can calculate here the voltage. Okay. So first you can give the equivalent because they have the capacitor here connected. So we have written the equivalent capacitor and these 25 and across this voltage have the 25 only. Okay. So now here, so these two is became a one capacitor by adding and these 4 and 1 they have the parallel here. So we can written here the 4 into 1 divided by 4 plus 1. This is the parallel indications. So it became 4 divided by 5 and this value, capacitor value became 0.8. So 0.8, again you can draw the circuit diagrams and write on the capacitor value 0.8 microfarad. Now here across the capacitor voltage is there 60 and here 10. So this you manage here and then became here 50 volt. So output voltage here V of 0, what you get here 50 volt and here tau equal to what? This is the RC circuit. So we have written R and C. So R value how much you have? 25 and C value how much have? 0.8. Now multiply this and it gives 0.02 second. Now second you can change on the microsecond. So it became the 20 millisecond. So now get the time here 1 divided by tau equal to what's the value for the second? 0.02. So 1 divided by 0.02 equal to what? 100 divided by 2. So it became the 50. So output voltage of capacitor you can get a 50 exponential minus 50t when is t greater than 0. That means switch is on. So voltage is became decreases across the t. Okay. So now I will stop here.